guys, welcome to Civil Engineers Adda. So today we are going to see modeling of a single story building, and I'll carry out the analysis in the same video. So let's begin without wasting the time. So let's take YZ axis, sketch, and just take a line command here. So just we'll select 3000 mm, that is 3 meters, and we'll take the span of 5000 mm here. So we have 5000 here, and again the same thing. So now here we just take the span of 3000 mm. So let me pull this back here, okay, and drag this back. Now again 3000 mm column. So guys, this is done. So what I'm going to do is just I will bring it in an isometric view. Okay, so fine guys, so this is done here. So what I'm going to do, I'm just going to select all the curves here and just say it as prepare, then rectangular. Okay, one thing I need to just confirm you that let me select the control Z. Let me go back to this view here. Last column, it is of 3000 mm. Oh sorry, this is a little bit more. So 3000 exactly. So 3000 exactly, 3000. So this is done actually. So this is done. This is 3000 mm. Now what I'm going to do is I'll just select the columns. Let's select only the columns here, because the columns cross section of the columns is different. So I'm just selecting the columns here, then say prepare, and just select the rectangle cross section, just beam profile, rectangular, edit beam profile. So now the base here is I'm just selecting this as 300 mm, and I'll just select the height as 450. The depth is 450. So just let's see the cross section. Okay, just guys, okay, this made the cross section, fine. So let's not worry about that. So the columns have been done now. So let's select the beams actually. Let's select the beams. Fine. I'm just selecting the beams, again prepare, just select a rectangular section for beams separately, and let's go back to the profiles here, and you just select the rectangular 2, and the beam. So let me select the beam depth as beam, the width of the beam. Let me select the width of the beam as say you have to select them as 230 mm, and let me take the height, or you call the depth as 350 mm, or let it be as a 300. So for that matter, let it be 300. Okay, fine. So guys, let's go back to the design part here. So your beams and the two sections have been assigned, that is a rectangular section and rectangular 2. This is for column and this is for a beam. So guys, this is done. So just what I'm going to do, just let me select this and just come back to the design part here. We're going to replicate this option here. So let's replicate them. Let's select one dimensional. So let me just drag this here. So let us make a count of 3, and let us give the pitch of, say, let's give a pitch of 4000 mm, just to think 4 meter span. So we have to select the direction, guys. So let's take this direction. So this is done. So just be careful, like you have to select the create the pattern green color, means which means you're okay with the dimensions and everything. So now what I'm going to do, I'm just going to create the side beams here, the longitudinal beams. So for that, you just select the rectangle here, just select your just, just select the ISO, just select this path here. So just pull that pull the drawing command, just pull it by 3000 mm, which allows you to connect the nodes directly, which allows you to connect the nodes directly, guys. So what I'm going to do, just connect the nodes directly. So this will be a time saver for us. If otherwise, it will be a time saver, guys. So now same thing repeat. I hope you are enjoying this. Okay, fine. So just come back to the 3D mode here now. So these parts have been not selected. These sections have not been assigned. So let's assign them. Just select them and just go to the prepare, and there you can select your rectangular 2. So after selecting them, you can just see those things have been selected successfully. Okay, so just let's select this material, everything here, and just see that display. We'll see this as a solid beam now. So guys, just see the beams solid, all of them have been assigned successfully. So guys, now what I'm going to just come back to a wireframe, and now what I'm going to do is I'm just going to create a slab here. Okay, so you need a slab for that matter. So you need a slab there. So what I'm going to do, just create a fill here, and I'm just going to combine here. Just select all the four things and just hit complete the fill option. Yes, guys. So it has filled now. Now just select here, and again green button. Just select all the four corners, otherwise it will not take. So you should select all the four corners here. So again green button. So done, guys. Just hit escape. Just so guys, we have created the model. Let's check the connections between the beams, columns and slabs. For that you need to go to the workbench here, and then you have to select as share. You have to select as share. So it gives you a command saying that it has found 12 edges. Okay, so this is done. Okay, so fine. So now what we'll do, just we will select this once again. Let's select this once again. Let's see, there were no objects to share within the specified tolerances, which means that your entire model has been selected successfully. So which means that there is nothing to share. Okay, so guys, this is done now. So the part of Ansys, the design, the modeling has been completed with your complete intact of the drawing. So let's go back to the structure here. So we have to see these all the things. Okay, fine. So let's go back to the workbench, and we'll just select the static structure analysis. We'll just do the static structural analysis, and we'll see some other analysis, single story. Okay, story 1. Okay, so fine, just link the geometry here. And now for engineering data, we're going to just select the material, that is concrete. That's the general material. We're going to select the concrete. We have to load that material here. So just select the concrete here. So where's the concrete? Yeah, definitely. This is the concrete. Done. So just come back to, we have selected concrete. So just come back to the project, and now you have to open the model. So let me resume when the mechanical uh, opens. Okay, so guys, the mechanical enterprise Ansys mechanical has been opened here. So what we have to do is, let's drag this down a little bit for just a good view. Now we have seen that the surface here has a question mark, which means the surface is not defined yet. So let's see what it is required to do. We have not selected the thickness. Okay, you have to select the thickness. Let me give the slab thickness as 200 mm for now. Actually, the minimum is 150 mm according to IS 456. So according to code, so let me give you here as 200 mm. And now let's select the material. Okay, so we have to select the material as concrete. So concrete, yeah, it's done. So the beams and other things, they also should have been selected as concrete itself. So just select them as concrete. So this is done. Now materials, everything is done, so we have to go for meshing. Default is going for 500 mm. Okay, will not disturb that. We just say generate mesh. Okay guys, you're just able to see that the model has been created successfully. This is a single story. Just it will give you a side the idea of how the structure behaves and how this analysis works out. So it's not doesn't matter if you're doing for 10 story, but if you're understanding how it works out for a single story, then the same things can be applied for a G+4 structure, which I have explained in my previous video. So let's insert a fixed support. The column will be fixed, so we are inserting the fixed support. Just go to this view and just select the box, select here, take a vertex selector, just select. Okay, so now you will be able, you are seeing that the 9 vertices have been selected. So 1 2 3 3 threes are 9, so it's done. So just okay, so fixed support has been done. Now initially what we are going to do is that we are going to apply a we are going to apply a standard earth gravity. Okay, we'll just apply a standard earth gravity, and what we are going to do is we are going to apply the standard earth gravity in the negative y direction, that is the downward direction. Negative y itself is the downward direction, and we'll just see like how the structure behaves. So I'll just say it as a solve. It will not take much time here, so I'm just moving, just not turning off the screen, so it should not take much time. So you're just seeing that it's 85% done. So everything has been executed successfully. Let's insert a total, and let's go for the maximum results that we can understand from this diagram. Okay, so we'll see the maximum principal stress, maximum principal, and we'll just see the strain in the regarding to strain. We'll see the strain intensity, maximum principal strain. We'll just see the normal strain. Okay, normal strain. So all those values will be just we'll just see them. Maximum stress. Okay, then we are going to add the normal or stress intensity. We'll just add the normal stress here. We'll just see that energy linearized this thing. Okay, we'll just evaluate all the results. So it will take 2 or 3 seconds to do that. So just guys, just see this. Just see the type of deformation. If you are going to see it as a total deformation, which includes the x, y, and z planes. So just we'll run the animation. Okay, fine. So just see here. So I think the maximum deformation is coming. Let's probe the values. Okay, so the maximum deformation is coming at this span, which is I think the span is large here. We have considered a 5 meter span, so I think the deformations are coming large, quite large there. We'll just see the directional deformation. In that, I want to see particularly the y-axis deformation. So let's again solve that. Evaluate all the results, guys. So just see. Okay, fine, fine, fine. So in the y direction, the intensities, you're able to see the intensities here. Okay, so just see that the blue color indicates that the directional deformation in y-axis. Okay, so this is done here. So you can just see while doing the connections, each and every part are held up here. So that's the best thing that we have to do. Okay, maximum principal elastic strain. Okay, maximum principal elastic strain. The maximum strain occurs at this point. So and its value is around it's giving you a value here only. You can just see here this value. So let's run through the animation. So guys, just see how is it acting. So just see how is it acting like. Just let's see this exactly in this way. So you're able to see that the Ansys is doing its work brilliantly, and the things. Okay, so just we'll stop here and we'll go to the normal elastic isometric view. Okay, so this is a normal elastic strain. So this is a normal elastic strain. Normal elastic strain. The elastic strain is the one which can be, the strain can be just reversed back to its original position when the loads are released. So you can just see strains are maximum at these junctions, at the corner points where there is a continuous slab here. I think there's a direct impact, or the beam is suffered. This beam, the beam here is suffering, the middle beam here, it's taking a lot of load or is under maximum stress. So now we have to see the maximum principal stress. Okay, so it's rotated. Okay, so let's run this animation here. Maximum principal stress. So just you can see that it's not so my there's no such maximum principal stress here. So you can just see here, this is the maximum principal stress. And normal stress, we are again same thing that is illustrating for the normal elastic strain. Okay, so guys, now what we are going to do is we just check out with the we just see that the beam results. Let's see how to obtain the bending moment and shear force results from this structure. So let's check the axial force first. Okay, let's check the axial force. So let's see if something we have to change here. So nothing as of now. So okay, fine, just evaluate all the results. So guys, just see the axial force here that is generated. So the beams have been subjected to a lot of axial force. So they have been subjected to a maximum, that's 498.55 maximum of the pressure here. So just see the the way in which it behaves. So let's take this for 4 seconds and the frames for 40 frames. Okay, and just we'll run through the animation again once again. So just here, how is it behaving? So let's see this for just 3 seconds. So then only you'll understand the movement. So just see this. Okay, fine. So we have got the axial force now. Now what we are going to do is we'll just insert a construction geometry, that is a path here. So that path defines the edges. Actually, let's take the single select. Let's define the edges. We'll not take the 2 points. We'll just go by the edges here. So select this edge. So this is your one edge. Okay, so this is a one edge. Oh, so I think it has taken in this way. So let's delete this path here. So we just insert the path again, once again. So be careful here. Just select this path and just it's taking 2 points. Just select here as edge once again. So everything here, just select this edge here. Yeah, done. So one more path we'll just select here, guys. So let's take this path here along the edge of the beam here, and so this will be our second path here. Okay, again same thing, sorry guys. We have to select the edge there. Before doing that, to select this. Okay, this is your second path, or the direction where I require the stresses, maximum principle. And one more construction geometry we are going to do, one more path here. What I'm going to do is that path I'm just going to take along the middle line here. and to select this thing also here. So guys, just I think you're scolding me now, or let's see, once again we'll do this. So we'll select this path. Okay, so this is done. Now one thing we'll take is for column, we'll just select one path for the column. Insert path for a column here. Let's take this as as an edge, and this one. So this is done, and we'll take for a center column here, and we'll just select this one path again. We'll just make here this as an edge, and for the center column we'll just apply that. Okay, done. So all the paths have been selected now. So let's start inserting the beam results here. We'll just select the bending moment. So it just asks total bending moment. It doesn't ask us anything specifically. So just see this. This is a total bending moment here. So let's select this as a 2 second. That is the auto mode. Just see the way it is behaving. So the beams are getting stressed, and there's a slight movement. Okay, just see here. So you should see just there's a slight movement here. The columns are suffering a slight movement here. So we just get to know that by drawing the plots here. And then we have to insert the next one is torsional moment. Also we have to insert that and evaluate all the results. Okay, just see here. There's a maximum torsional moment at the point where there is a column at this position. So just run through this analysis. Okay, just see there's a maximum torsion here. Okay. So I think there's a small error in the connection gap here. That usually happens if you are taking a model, just a general model to represent the things. So this is just I was explaining you how to do the analysis. Okay, so for the deep analysis again, you can just see, check out with the modeling and other things. Okay, now one more thing is actually we are going to see is shear force, guys. For shear force also, there's no such requirement of a specific path. So evaluate all results. So you can just see the shear force representation is been done here. So the shear force again, the maximum, those things are done. So it doesn't show in your. So the maximum shear force is affected on the column here, having the spans both on four sides spans. So one more thing, last thing, what we can just see is that we can see the shear moment diagram. So this part will ask you the path. Okay, this part will ask you the path. So what I will do, I'll just go for the path 5 first, and I'll just ask it to solve. Okay, fine. So guys, just see this. How is it behaving in this way? Just see this, guys. So it's behaving in this way. There's a bending here, so you can just see the graph here. So this is your bending moment diagram. So this is the bending moment diagram. Total shear force against total displacement. Okay, so the maximum displacement is 0.133 mm. Okay, so 0.3133 mm at 500 mm, means at 500 mm from the bottom of the column you can see a deflection of 0.13 mm. Okay, it's showing an exaggerated scale. So let's come back to the geometry here. Let's see that again we are inserting beam tool, that is sorry, shear. Again, one more thing, once we'll insert again this beam result. So we have one, two, three, four paths. So other, again, same thing here. So let's repeat this again. One, two, three, four, five, done. So now we are going to select the path as P4. Now again we are going to select here the path as P3. Again here P2. And the last one is path 1 or path, simply path. So we have to select all the results here and ask them to solve. So all the results have been solved. So we need to just go to the geometry and we need to check out each part here. So just see this graph here again. Let's check out the geometry first. So this geometry, so you can see, let me run through the animation. Again, you'll just see that the column is deflecting or it's buckling a little bit towards the x direction, in the path of x direction. So let's see the diagram 3 here. So guys, just see the diagram 3. So you're able to see that the maximum bending moment, or there's a total shear force that is absorbed. So just see here. Okay. So one more thing that we can just see here, that we have selected the column. I think this is the column selected here. Okay, fine. So column is okay for us now. Okay. So just see, this is the axial force actually. So this is the total shear force, that's the axial force. Okay, so guys, I think you're able to see all the things, diagrams and other things. You'll get an idea here. You'll get an idea regarding the total shear moment diagram. Okay, so I think this was helpful to you. So let's come back to the geometry. I think this video is running very long. So just come back here. So let's insert one more thing. Let's flexible rotation, force reaction. So let's see the force reaction. Boundary condition is fixed support. So let's see, evaluate the results. Okay, so you just see the force reactions here. Okay, now, so guys, thank you for watching my video. Please do subscribe my channel and do more videos on Ansys. Please subscribe and like the video if you like it, and just share the video to your friends. I'm putting a lot of efforts. Please do me a favor of sharing this video to your friends, and like this video to the maximum views. That will provoke me to do another video on this, of this type. So thank you guys.